We have seen few methods for an array list. So how to declare an array list, the two different ways how to declare, and how to add elements to the array list, and how to iterate through the array, all the collection items, and how to add group of elements to the array list, and how to convert it to array. So these are few methods that we have seen in our yesterday session. So we'll continue with the same thing. We'll see few more methods that we can access using the array list. So suppose, so iterator will iterate through each and every element of the collection. Suppose if I want to get a particular element of the array list, then we have a method called get. Suppose if I want to print a third element of the array list, only third element, how can I get it? The third element of the collection is al.get. So get is the method which we have in order to retrieve any particular element of the collection. So in this method, you have to pass the index value. Now you want to print the third element. So the index will be 2. To print the third element of the collection, the index will be 2. So for array, line number 37, this is how we get an particular element of the array. But whereas for collection, we have a method called get. So get is the method to get a particular element of the collection. So let me save this one and run this program. So the third element of the collection is 12. So 10, 15, 12. 12 is the third element. So 12 is printed. Okay. So this is one of the method, get method. Now we will see, we have seen size also, right? So we will see remove all. If you want to remove any particular, any group of elements from the collection, then we use remove all. We'll see this method remove all. Now, list EL, array list EL contains all the elements of AL and also 23, right? So list L contains all the elements of array list AL, and in addition to that, it contains 23 also, the element 23. So let me run this and show you what does this L array list contains. So the elements of L array list are 10, 15, 12, 13, 25. And also these are the elements of the AL list. And also along with these array list elements, we have one more element called 23, right? Now from this list array list L, I want Naneshwar, can you please go on mute? Okay. So from this array list L, I want to remove group of elements. Like I want to remove all the elements from this collection. What collection? AL collection. So I want to remove all these elements from the list L. So in that case, we can use this one. L dot remove all. So if you want to remove a particular element, any single element, you can use the first one and give the index and remove that particular element. Remove all will take collection. It will take a collection. Okay. So remove the first one. So this we call it as method overloading. Remove method can, the same method name remove with different parameters. The first method takes the integer parameter, whereas the second remove method takes the object parameter. So this we call it as method overloading. Here, if you use the remove method, it will remove only one particular element based on the index which we provide. If you use remove all method, it will take collection. It will take a collection. Okay. So it will take a collection and remove all the elements of this collection. Now I want to remove from this list L, I want to remove all the elements which are available in this AL collection. Okay, let me show you here.
Suppose I want to remove only one value. That time will only remove.
Yeah, remove. I'll show you that as well. Okay, let me show you that one only. Before this, L dot remove. Index you can provide. So 0th index I'm providing. Okay. And now let me print that. system dot order println the elements of L array list after removing first element. Now let me print L. Save this one. Okay. See, the first element was 10. Now the first, after removing the first element, the next element is 15. So 15, 12, 13, 25, and 23. These are the elements of the L array list. Now we are using remove all. The next method is remove all. Now what will happen is, from this list L, what and all elements that are present in AL, all those elements will be removed. For example, this is the AL, which contains 10, 15, 12, I think 23, right? 12, 13 and 25. 13 and 25. This is the list L, which we created using AL and 23. So elements of AL plus 23. What are the elements of AL? 10, 15, 12, 13, 25, and also with that we added 23. Okay, these are the elements of the list array list L. Now we have removed the first element of this list. So 10 is removed and we have only these elements 15, 12, 13, 25, and 23. So these are the new elements of array list L after removing this first element, right? Now what we are doing, L dot remove all of AL. So here remove all will take only collection. It will take only collection, similar to add all. L dot add all of, so add all, it will take a collection, right? The same way, remove all also will take a collection. Now we are providing AL is a collection, right? AL is a collection. So the elements which are present in AL will be removed from this array list L. So what are the elements that are present in AL and L? So what are the elements which are present in both L and AL? So 10, 15, 12, 13, and 25. 10 is already removed. So now it will remove 15, 12, 13, and 25. I can say this as, I think you will be very familiar with the mathematics sets, right? So this is AL and this is L. So AL contains 10, 15, 12, 13, and 25. This is L set, which contains 15, 12, 13, 25, and 23. Right? Now, L dot remove all means L minus AL. The elements which are present in AL and L, common elements will be removed. Other than that, what are the elements present? Only that will be available in this L. So the common elements are 15, 12, 13, and 25. These are the four elements which are common in both AL and L. All those elements will be removed and only 23 will be there in L. So it will be L. Now the new array list will contain, new array list L will contain only 23. So remove all will be similar to L minus AL, A minus B in sets, in mathematical sets. If this is A set and B set, A minus B is nothing but remove all. Okay, so now if you print the output of this, let me print the output of L again. The elements of L array list after remove all. So what will be the elements available? L. Save it. So only 23 is present now. So remove all is similar to A minus B in mathematics. Now the next one is remove if. Remove if is based on condition. It will remove the elements of the array list. So if you gives any condition, based on that condition, it will remove. Okay, let's see that how it works. Now the list L contains only 23. So let's take AL array list. AL array list which has 5 elements. So we'll use AL array list. AL dot remove if. Here you have to give a condition, Boolean condition. Condition you have to give. So what will be the condition? So condition, so I'll give a condition like this. X is such that X is greater than like 50. So this is the condition. How I'm writing the condition here is, so let me show you here. Now remove if. It will take a condition here. So what is the condition I'm taking? So for each element of this array list, AL array list, X such that X is greater than 15. So first element is 10. So X value will be 10 initially. So it will check the condition. Is 10 greater than 15? No, it is false. If it is false, then it will not remove that element. So it will remove the element from the array list only if the condition is true. Only if the condition is true, then that elements will be removed from this array list. So this will not be removed. It will not be removed from the array list. The next element is 15. So the X value will be 15 now. It will check the condition. Is 15 greater than 15? No, false. This element also will not be removed from the array list. The next element is 12. So it will check the condition is, here it is 12 greater than 15? No, it is false. So this also will not be removed. The next element is 13. 13 will be stored in X such that X is greater than 15. Is 13 greater than 15? No, false. So this also will not be removed from the array list. Now the next element is 25. So it will check the condition here. 25, is it greater than 15? Yes, it is true. Now this element will be removed from the array list. This element will be removed. Now the final AL contains, what are the elements that it will contain? 10, 15, 12, and 13. All the elements which are greater than 15 will be removed. Elements which are greater than 15 will be removed. So if the condition is true here, those elements will be removed from the collection. If condition is false, those elements will not be removed from this collection. Clear all of you? Now, if you run this program, and now if you print the AL array list, AL after remove if you print the output of this AL, see it printed only 10, 15, 12, 13. The elements which are less than 15 only it will take. The elements which are greater than 15, those will be removed if the condition is true. Okay. The next method is size we have already seen. We will see clear. Okay. Clear we will see at the end. So that for now we will see what is retain all. Clear at the end of all this method we will see. Now we'll see retain all. Retain all is opposite to remove all. Okay, the elements which are present in the collection, so this will also take collection. What and all the elements which are common in both, it is similar to intersection. Okay, let me show you that. Okay, retain all method, it will accept a collection. So we have to give a collection here. Suppose AL dot retain all of, so L is also a collection, right? If I give L like this, AL will now contain the common elements in both these array list. What are the common elements in both these array list? Those elements will be available in this AL array list. As of now, there are no common elements. AL contains 10, 15, 12, 13. L contains only 23. So A retain all is similar to A intersection B. A intersection B means common elements in both the sets. In A set and B set, what are the common elements? That will be equal to retain all. As of now, here there are no elements available, no common elements available. So AL contains 10, 15, 12, 13, and L contains 23. Suppose if I add 23 here, if I add 23 to AL, then retain all method will return only 23, and AL also will contain only 23. So retain all is nothing but intersection, common elements in both these array lists. What are the common elements present in both this array list? Okay, now let me add 23 to AL. AL dot add of 23. I'm adding. Okay, now let's see system dot out dot println. Before this, let me AL dot retain all of collection L. L is the collection we are giving here. So common elements in both AL and L collections. So that will be remained in the AL collection. So if I print the elements of AL after retain all. Let's see. So if you print this one, it will give you output of 23. So 23. So it gave the output of 23. Retain all will be similar to A intersection B, which means common elements in both the collections. The next method is equals. In order to check two collections are equal or not. As of now, AL contains 23 and L also contains 23. If you use that equals method, it will give the output as true. That means both these array lists are equal, because AL contains 23 and L also contains 23. If you check the equals condition, is if AL is equal to L, then it will return true because the elements are same. If any one contains any one element extra, suppose if I add any element to this L collection, if I'm adding 16 to this L, and you're writing the, you're checking if AL dot equals L, you're comparing these two collections. AL collection, you're comparing it with L collection. As the elements are different, AL contains only one element, whereas L contains two elements. One element is extra here, so it will return false. Exact comparison it will check. All the elements it will check. If they are equal, then only this will return true. Otherwise, it will return false. So that is the equals method. As of now, AL contains 23 and L also contains 23. So equals method will return true. Let me show both the cases where it will return true and where it will return false. So if AL dot equals of L, then system dot out dot println, both the collections are equal. Else collections are different. Okay, now let me run this program. So as the elements in AL is 23 and in L also it is 23. So that is why these two collections are equal, and the condition the method which we use to check this condition is equals method, and it returned true. So that is why if block got executed. Otherwise, if suppose now let me add an element to the L. So L dot add of 16. I added 16 here, And now if I check if AL dot equals of L, it will return false. So it is written false and it went to the else block. It printed collections are different. Okay. Now the next method is to array. We have already seen. Then the other one is contains. Contains, right? So this is to check if an element is available in the collection or not. If the element is available in the collection, then it will return true. Otherwise, it will return false. Okay. So here, if AL dot contains 23, this is the element. Okay. If it contains 23, system dot out dot println AL contains 23. Otherwise, else system dot out dot println AL does not contain 23. Okay, this is the contains method. Let me save it. As of now, AL has this element 23. So it will return true and if block will be executed. If I run this program, if block will be executed, so it will print AL contains 23. If AL, so let me check with any other element. Suppose I'm checking with 16. So AL does not contain this element 16. So the else block will be executed. Okay. So AL does not contain 23. Sorry, it should be 16. I hard coded it, so it printed like this. Now, contains all. Contains all will take collection. Suppose I want to check if L contains all of AL. So it will accept a collection. If I'm checking if L contains all the elements of AL collection. If L contains all the elements of AL, then this will return true. Then this will return true, and if block will be executed, it will print L contains AL. Otherwise, L does not contain AL. Okay, so it takes the collection. L has the elements 23 and 16, whereas AL contains only 23. So can someone tell me which block will be executed? Either if block or else block. The elements of L are 23 and 16. The elements of AL are 23. So can somebody tell me which block will be executed? AL contains only 23. L contains 23 and 16. I have written the statement like this. If L contains AL, L dot contains all of AL. Will this statement return true or false? Can someone tell me?
Contains all.
Yeah. So L is a collection which contains 23 and 16. AL collection contains 23. Now I am giving L, if L contains all the elements of AL or not. Will it return true or false? Pratima, can you try? Will this condition return true or false? Pratima, are you there? Karthik, can you try? Hello?
Yes, yes.
So can you try? What will this condition return? Will it return true or will it return false? So AL has two
True
elements.
only.
Okay. Yes, that is true because L contains 23 and 16. That means it also contain AL, right? AL is only 23. So 23 is already available in this L. So that means L contains AL. This will return true. Okay, so this will return true and it will print L contains AL. If I run this program, L contains AL. So other than this 23, if any elements are available, suppose let me add AL dot add of, I will add 45. Now AL contains 23 and 45. Here AL contains 23 and 45. L contains 23 and 16. What will this condition return? What will this condition return?
False.
Yes, false. So now if you run this program, it will return false. L does not contain AL. Okay. So these are the basic methods that we have. Iterator we have already seen. Peak, element, pole, and remove we will see going forward. For array list, these are not needed. Going forward, we'll see all these 4 methods. Apart from that, we are pending with clear. So we'll work with clear now. I will write al dot clear. So, okay, clear. And now I'm trying to print al. Elements of al after clear plus al. Let us see what it will do. See, it removed all the elements from al. All the elements from al are removed now, and by default it will set to some default value. Suppose if I want to print any element of system.out.println al dot get off, I will print okay, 0th index value only I'm trying to print. Let's see what will happen. It is throwing index out of bounds exception because all the elements from al are removed. And now if you are trying to access any element of the array, of the collection, it will throw index out of bounds exception. At 0th index, there is no element, but you are trying to access the 0th element, 0 indexed element. So it is throwing an error here. What is the error? Index out of bounds. That means the index which you are trying to access, that is not available. It is out of bounds. Okay. So these are all the methods, common methods we have seen for array list. So are all the methods clear for you? Any doubts in all these methods till now which we have discussed? Apart from peak, element, pole, and remove. All of you, are all these methods clear for you? Okay. Now, it's the same thing if I use with peak. Okay. Let me try with peak. Al dot peak. One second. Sorry, we cannot use this with peak. It can be used only with the queues. The first element and the last element. So all these things we can use with the queue only. So do not touch this array list. So any doubts till now in all these methods? Can we go to the next category of collection, list collection? So for list, we have 4 different types. First one is array list, we have seen. The second one is linked list. Can we move to the second one? Okay, so the next kind of list is linked list. The coding will be same, but internally how that works will be different. So when I write the code for linked list, you will not find any difference between array list and linked list. All the methods will be the same. Declaration also will be almost the same. Everything will be the same. But internally, how it will work, that will vary. At interview point of time, they'll ask you how the internal operation, how internally all this work. Only those questions only they will ask you. How linked list works internally, how array list works internally. And so they'll ask you these kind of questions because coding wise, you cannot see any difference. Okay. So now linked list. how it will work internally. Suppose this is my linked list of type integer LL. Linked list is equal to new linked list of type integer. So this is the declaration. Now I want to add a few elements to this collection. So LL dot add of 10, LL dot add of 15, LL dot add of 23. So I want to add these three elements to the linked list. Now, linked list, the name itself says link. There will be a link for each and every element. So now, how the elements will be stored internally is, for each and every element, there will be 3 blocks. Suppose the memory address of this block is 1000. Okay. In the middle block, it will store the data. So what is the data here? 10. So in the middle block, it will store the data. In the first block, it will store the address of the previous element. So here it will store address of previous element. As of now, there is no previous element. This is the first element. So this value will be null. Okay. Now, in the last block, third block, it will store address of next element. As of now, there is no next element. We didn't add it. So at this line, this will be null. This will be null. Whenever you add a next element to this collection, now at this line, you are adding one more element to this collection. So what it will happen? One more memory with 3 blocks will be created. Let the address of this be 1010. Of this block be 1010. So at the middle block, it will store the data. What is the data? 15. So in the first block, it will store the address of previous element. What is the address of previous element? What is the previous element? 10. For this, where this 10 has stored, 10 is stored in the address location 1000. That address will be stored here. And this will be pointed to this like this, to the previous element like this. Now 10 has next element. After 10, 15 is added, right? So here, instead of null, let me remove this. Instead of null, now it will store the address of the next element. What is the next element to 10? It is 15. What is the address location of this 15? 1010. That will be stored here. It will be 1010. And now it will point to this data. This is how a link will get connected between these two elements. There is a link. A link will get created between these two elements. Now, this is done. When one more element is getting added to this linked list, 23 element is added to this linked list. So as of now, there is no next element for the second element. So it will be null. When third element is added, third element, which is 23 will be stored here. Let the address of this be 1020. Okay. 23 will point to the previous. So this block will store the address of previous element. The previous element of 23 is 15. So what is the address of 15? It is 1010. So 1010 will be stored here. And this will point to this previous element like this. And now the next element for 15 is available, which is 23. And the address of 23 is 1020. That 1020 null will be replaced with 1020 here. So initially it was null. Now it will be replaced with 1020. It will be 1020. Now it will point to this address location like this. And now there is no next element for this 23. So it will be null. So when you add a new element, this null will be replaced with the address of the next element. This is how the links will be created whenever you add any element to this linked list, to the collection. So you can using these links. So you can traverse from each and every element like this. You can traverse in both the direction. Either from first to last you can traverse, or from last to first you can traverse, because in both the direction the links are available. This is the first element is linked to the second element is linked to third element. So like this, you'll, for all the elements, the link will be available. In the forward direction, you can travel. In the reverse direction also, you can traverse. Because you have the addresses. So addresses you have for the previous element and the next element. In this way, you can navigate with each and every element of the linked list. This is how internally linked list works. Apart from that, all the methods will be the same. ll.addAll. So whenever you're adding any list or any collection or any element, this is how the links will be generated. Links will be created internally, and it will maintain a proper order. This is how it will maintain a proper order. So list means it will maintain an order, right? So for linked list, this is how it maintains the order. Is anyone having any doubt? Dinesh, okay. Okay, let's see how we can write a program for linked list. All the methods, like how to iterate through linked list, how to add all, how to convert it to array, everything in coding part that you cannot find any difference, but at runtime only how internally it works, that will vary. So at the interviewer will ask you the internal operation, not the coding, because coding will be the same. So now if I create a new class for linked list, I'm creating a new class for linked list. Okay. List of type integer. LL is equal to new linked list of type integer. Okay. Let me import these classes. Import it from java.util. Okay, wait, correct. One second. Why it is not allowing? It should allow. Why it is not allowing? 1 second. This is also integer. Oh, sorry. So I gave the class name as linked list. So I'm trying to overwrite it. That is why it is. So already this class is available. Linked list class is available. And now I'm again trying to create the same class, linked list. So that is why it is not allowing to do. So let me change the name of our newly created class to linked list demo. Okay, and the file name should also be changed, right? So rename file name to linked list demo. Now it will ask you to import. So import linked list from java.util. So if you are trying to create the already existing class, so this is the issue it will throw. So the class name was linked list, and the one which I want to import was also linked list. That is why it was not showing the suggestions properly. Now, when I change the class name, which I am creating now, to linked list demo, it is working fine. It allowed me to import linked list from already available java.util. Now, if I want to add elements, so I can use add. So 13, let me add few elements. ll dot add 25 or 56. ll dot add 34, like this. So I've added 3 elements. Now, if I try to print the elements, linked list, these are the elements. Element. Okay, now if I print the output of this program, so it printed 13, 56, and 34. Now let me try to use for each loop. Okay, for each integer in this LL. So I want to perform some certain mathematical operations. Let me do that. System.out.println multiplying by 2. So integer into 2. So if I try this, so for each and every element of this LL will be assigned to integer. Integer is a variable here. So let me take even like this, I. So I is a variable here. So LL, the first element is 13. 13 will be assigned to I. And now this I, what is the mathematical calculation we are doing? Multiplying with 2. So 13 into 2, 26 will be printed first time. This loop will be repeated again. I will store the 56 element and it will be multiplied by 2. It will print the output. The next element is 34. 34 will be assigned to I and 34 into 2 will be printed. So let's run this program. See, multiplying by 2, 13 first it will be multiplied by 2, it is 26. 56 is when it is multiplied by 2, it is 112. And 34, it is multiplied by 2, it is 68. So this is how you can use for each loop to iterate through each and every element. Otherwise, if you want to use for loop or while loop, okay, that also we can do. If I use for loop, int I is equal to 0, I less than ll dot size, okay, and I plus plus. System dot out dot println, and this time we will do addition. Adding 10. We'll add 10. So ll dot get of I plus 10. Sorry. Okay. Now, if after adding, so ll dot get of I means it will get the element. So that is the difference between for each loop and for loop. So in for each loop, every element will be assigned to this variable I, and directly you can use that variable like this. But whereas for loop, you have to use the method get of index. What is the index? I is the index we are taking. So this is how, that is the difference between for each loop and normal loops. Okay. So now if I run this program, so adding 10, 13 plus 10 is 23, 56 plus 10 is 66, and 34 plus 10 is 44. Okay, these are a few more iteration things that we can do with using for collections. So if you want me to take example and explain for any of these method, you can ask me. So I'll take an example and explain in all. So whichever method you have any doubts, if you ask me, I'll explain that. So for now, you leave these last 4 methods. Apart from that, if you have any doubts in this, any of this method, you can ask. That I'll explain for linked list. All of you? Are all the methods clear?
Yes, ma'am.
Okay.
Suppose if I want to remove the middle of the value, how we can remove?
Indexing we have, right? Suppose now if you want to remove middle means 56. 56, what is the index of 56? It is 1, right? Index of 56. So I can take it, remove of index. First index.
Okay.
You run this program. Why it is still contained? 1 second, let me run it again. Okay. Now it is removed. See, it contains only 13 and 34. 2 elements only, it printed the output. So if you want me to explain any other method?
No, no.
Okay, so we'll go to the next
Understood.
one. Yeah, the next one is vector. The next type of list is a vector. There is a small difference between an array list and vector. We'll see what is the difference. Array list is not synchronized, whereas vector is synchronized. That is the main difference between array list and vector. Apart from that, the internal operations, everything will be the same. Okay, so array list and vector. There are small differences between these two. Array list is not synchronized. That means if you define any collection using array list, then there is a chance of crashing. So it is not thread safe. Array list is not thread safe because it is not synchronized. Okay, but whereas vector, it is similar to array list. Internal working is all same as array list, but the difference is it is synchronized. This vector is by default synchronized. It is synchronized. That means it is thread safe. Okay, and one more difference is the memory will be allocated whenever you are adding an element to this array list. Suppose al.add of 10. This is of type integer. So for an integer, it will give 2 bytes of memory. So for each and every, whenever you are adding, when at the time of adding the element, the memory will be allocated. The memory will be allocated. But whereas for a vector, initially, for 10 elements, sorry, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, for 10 elements, memory will be allocated. So as of now, your vector contains only 3 elements. Okay, so 3 elements, say 10, 15, and 12. And you have added 8 more elements. So 13, 14, 16, 18, 40, 55, and 60. If the vector contains 10 elements, if you print the vector, suppose v is the vector, v dot size, it will print 10. After this 10th element, if you are trying to add any new element, suppose I'm trying to add 56. If you print v dot capacity, so v dot capacity is different and v dot size is different. I'll show you the difference between these two. The capacity is 20, but the size is 11. So what is meant by capacity is vector can hold 20 elements. Its capacity is 20. That means so whenever vector is created, it will generate 10, it will allocate memory for 10 elements. So first 10 are completed. Now, if you are trying to add 11th element, so this is the next element, right? So 10 more blocks will be allocated. This vector has now a capacity of holding 20 elements, whereas you have stored only 11 elements. That is the difference between capacity and size. This is also one more difference between array list and vector. Suppose in array list, you have added 10 elements. So for array list, you have added 10 elements. If you give AL dot capacity or AL dot size, both will be the same. So AL dot capacity will be 10, AL dot size will be 10. If you add 11th element, AL dot capacity will be 11 and AL dot size also will be the same, which is 11. But for vector, every time so it will target for 10 elements at a time. Once it is reached, and if you're trying to add any 11th element, its capacity will be increased by 10 every time. Its capacity will be increased by 10 every time. So initially you have added 10 elements and you're trying to add 11th element, its capacity will be increased by 10. So it will be 20. But the number of elements which you added is 11. It will show you with size method. Okay. So that is the difference between the vector and array list. Let me create a new class for vector. Vector demo. New this is the vector. Let me import the list and vector from java.util. Import vector from java.util. Now let me add the elements 13 v dot add of 43 v dot add of say some 35. I want to show if list allows duplicates or not. So let me add 35 again. Okay. Now let me print both the capacity and size of vector. System.out.println. The capacity of the vector is, we have a method called capacity. Sorry, for this you cannot. So why capacity method is not shown here is this method capacity will be present only in vector. So it only in vector class the method capacity is available. But if you are trying to access it using the object reference v, which is the list object reference, you will not be able to access that method. So see, if you are trying to access capacity method here, it will not show you because this method is specific to vector, not the list. List does not contain this method called capacity. It is specific to vector. So if you go into this vector, 1 second. So in this vector class, you will have lot of methods. So one among them is capacity. So where is the capacity? Let me show you. Ensure capacity. See here. If you observe carefully all the methods, so all the methods of this class are synchronized. If you see here, apart from this constructors, so vector is a constructor, class name, right? So this is the constructor. Apart from constructors, all the methods, if you observe, all are synchronized. See, synchronized. All these methods are synchronized. That means it is thread safe. If a method is synchronized, means it is thread safe. So capacity is also a method which is available in the vector. It is not available in the list class, list interface. So if you go into this list class, sorry. So in this list interface, you will not find the capacity method. So that is why using the object reference, you cannot access that capacity method. You have to create an object for this vector class, then only you can access this capacity method. It is not a overridden method. It is the method which is specific to this vector class. It is not a overridden method. So in order to do that, in order to access that capacity method, can take like this, take an object like this. Now, if you try to access this capacity method, it will be shown. Got the difference, all of you? Vector, this method is not available in the list interface. It is not overridden in vector. This method, capacity method, is available only in vector class. That is why if you create an object for vector, then only you will be able to access this method. Before this, we had object reference. That is why we were not able to access it. So now, this is the capacity. Now, if you print the size of vector plus v dot size. Let me save this program and run it. The capacity of the vector is 10. The size of the vector is 4. Suppose you add 10 elements to this vector and you are trying to add 11th element, then the capacity will be increased by 10. That means it will be 20 at that time. Okay. So whereas for linked list or array list, if you see, so in this, if you see, if you try to print the capacity, I don't think we can print the capacity because it is specific to only vector. Let me check if capacity is available for array list also. System.out.println. The capacity of array list is al dot no. So the method capacity is specific only to a vector. So it cannot access, but internally how it will happen is whenever you are adding any element to the array list, based on that, the capacity will be adjusted and it will be equal to size of the array list. But for whereas vector, every time if you are adding elements more than 10, the capacity will be increased by 10 every time. So got the difference, all of you? So that is one of the main difference between array list and vector. Internally, both will work the same, but array list is not synchronized, whereas vector is synchronized. Every time the capacity will be increased by 10 for a vector. Okay. All of you, is it clear? If you want to go and debug what is available in this vector, just mouse over or place the cursor in between this class and click on function F3, functional key F3. If you click on functional key, you will be navigated to that particular class. So this is vector class. You have navigated to that class. All of you, is it clear? Difference between a vector and an array list. And if you want to check the methods of array list, just place the mouse over or place the cursor in between the class, click on F3. You will be navigated to this array list class. Here you can find a lot of methods, but these are not synchronized. See, trim to size is available in array list as well as in vector also. You'll have that, you'll find that method. See, I'll show you. So trim to size, this is the method available in both vector and array list. But the difference is in vector, this method is synchronized, whereas in array list, sorry, where is that array list? Okay, this is the array list. It is not synchronized. So there itself, you can get the difference. Okay. That's all from my side for today. Tomorrow we'll discuss what is stack. So with that, we can wind up this list and we'll go to the next collection type. So if you have any doubts in this till now, you can ask me. Vector is older collection. So nowadays we are not using this vector. The most popular list collection is ArrayList. We'll be using ArrayList, but whenever if you want, you can use the vector also. If you want to make the data synchronized, you can go ahead and use this vector. This is the older collection type. Vector is the oldest collection type. Okay. So if you don't have any doubts, we can wind up this session. We'll meet in the next session.